Welcome to graphing a tan function. The equation we're working with today is y equals 2 tan times 1/2 x plus pi over 2 minus 3. And the first thing we have to do with this is to factor out the horizontal stretch of 1/2. And so we end up then with y equals 2 tan 1/2 bracket x plus, and when we factor out the 1/2, we're left with pi, close the brackets, minus 3. Looking at our transformations then, our transformations are, we have a vertical stretch of 2, a horizontal stretch of 2 as well. Remember, the horizontal stretch always is in inverts. We have a horizontal translation of negative pi, and we have a vertical translation of negative 3. That will provide us then with a mapping rule of xy maps to a horizontal stretch of 2x minus pi and a vertical stretch of 2y minus 3. And over on the right hand side of the board I have it titled the 5 key points of y equals tan of x, and you'll look and go, Miss, you can't count today, there's only 3 there. I only need 3 for this first part for setting it up. The other 2 will come in when we go to put in the plot the points in between. So the 5 points are still necessary because it gives us the asymptotes and 3 points to draw by, but to start with I'm only going to work with the 3. And you'll notice then the 3 that I have here are the 2 asymptotes where from the y equals tan of x, where we have undefined and undefined. Remember, that's our asymptotes. And I have the 0, 0 then as our inflection point. So looking at our mapping rule and coming up with where our new asymptotes and our new inflection point will be, we have then 2 times x minus pi. So 2 times a negative pi over 2 gives me a new x value of, that's the 2's are going to cancel, negative pi minus pi, so negative 2 pi. And my y at that same point is going to still be our undefined. So that's our first asymptote. The second asymptote then is going to be 2 times pi minus over 2 minus pi, so I'm going to end up then at 0 is my other undefined. And in between my inflection point, so 2 times 0 minus pi, so it's going to be negative pi, and this will take care, show my translation, 2 times 0 minus 3, and I can see where I have my inflection point. On my chart, on my graph here, you can see where I've already put in for dotted lines, the red dotted lines, my asymptotes. So the first one at negative 2 pi, this one here. The second one at 0, at 0. And I've put in a third one because we always like to draw more than just one period with the tan. We don't have to go wild, but showing 2 periods gives a good sense of what's happening. So I put in an extra one, but I know from the first 2 my period is 2 pi, so I just threw in another one at 2 pi later. Now to find my inflection point, find your negative pi, negative 3, and here's your inflection point. Now come those 2 other crucial points that we talked about needing for the 5 points to graph. When we did this discussion in class, remember I said that you would find that next one between this asymptote and your inflection point. It's going to be halfway, and it's also going to involve your stretch, your vertical stretch. So the vertical stretch then 2. And so we're going to go from this point halfway between down 2 from this point, halfway between, up 2. And there are our 2 points to follow. And remember, it's going to come close to the asymptotes, but never reach. And we can repeat that over here. So halfway between my 2 asymptotes, down my translated value of -3, grab a new point, my inflection point. Halfway between my inflection point, down 2 because of my stretch, 1, 2. From the inflection point to the right, up over the halfway, and then up 2, and draw in the graph. Because of my bar, I have that disjoint, but recognize that when you were drawing this without a metal bar down the middle of your piece of paper, yours would connect. There's a quick sketch of a tan function.